Okay, so I've got up here all the stuff that I want you to be able to do. I want you to be able to predict the products from reactants in a reaction. That's going to be new. Then we're going to balance the equation. Then we're going to write a word equation, and then eventually we're going to get to the stoichiometry piece. And I know stoichiometry seems a long time ago, and it has been. It's been 6 weeks ago. All right, but you'll be fine. So, might as well begin, well, at the beginning. Go ahead and write down the beginnings of this reaction, please. You've got Al, aluminum, added to LiCl, which is lithium chloride. Now, in answering the question of how do you do the products, how do you create the products, the first thing you have to do is identify what type of reaction you're dealing with. And remember, your choices are going to be synthesis, decomposition, single replacement, double replacement, and combustion. Out of those 5 types, what type of reaction is this? Is this beginning? Do you remember? Very good, it is. It's a single replacement reaction. Now, in a single replacement reaction, something to remember is that its general format is going to look something like this. A plus BC. Remember, this is what I call teenage dating. This is where the couple breaks up, right? BC breaks up. B gets kicked out. So, if this is a positive ion, this is positive and that's negative, basically what happens here is that the positive ions switch places. Your cations switch. So now I've got B out on its own, and now I have a new compound of AC. That's what's going to happen in this reaction. One thing gets replaced. That's why it's a single replacement. So, in finishing this reaction, you've got your reactants there on the left. That's the beginnings of a single replacement reaction. Knowing the format at the bottom, how are you going to finish the products? What gets kicked out? Lithium gets kicked out. Very good. Lithium gets kicked out, and now I have a compound of aluminum and chlorine. Can I just put AlCl? You can't. What do you have to do with that? I heard the beginning of it. Swap and drop. You have to swap and drop. Something easy, but it's also easy to forget sometimes. Anytime you are making a new compound, you have to swap and drop. So, what's my charge on aluminum? What is it? +3. Yep. And chlorine? -1. So I'm going to swap and drop, and I'm going to get AlCl3. So that is my final product, AlCl3. So I've done the first part. I've created the products from the reaction. I've finished the reaction. Woohoo. Now the next thing that you're going to need to do is balance it. Some of you are better at balancing than others, but we're going to kind of do it together. So I have aluminum, I have lithium, and I have chlorine. I'm going to put it in the same order on the right, aluminum, lithium, and chlorine. Remember, you're going to do your atom inventory. So on the reactant side, I have 1 aluminum, 1 lithium, and 1 chlorine. And on the product side, I have 1 aluminum, 1 lithium, and I have 3 chlorines. Law of conservation of matter says that you can't create or destroy matter. So I can't go backwards. I can't go down on my numbers. Instead, I can only use multiples. So I'm going to put a 3 where? Good. You're going to put a 3 in front of the LICL. Why? Because I need to get 3 chlorines. I can't go from 1 to 3. I need to have 3 to 3. So I put a 3 out in front of LICL. What does that do? Well, it messes up my lithium. It changes my lithium from 1 to 3, but it does take my chlorines from 1 to 3. My chlorines are good. My aluminums are good, but my lithiums are not. So on the product side, I can put a 3 out in front of lithium. It changes my lithium to 3. Now my lithiums match and my aluminums match. I'm good. Remember, I can leave those blanks empty if you want, or you can put a 1 out in front. It's balanced with a 1, 3, 3, 1. Now something that comes up, people always ask on this product side, does it matter if the lithium is listed first or the aluminum chloride? Makes no difference at all. So if you have it listed as AlCl3 first and then lithium, that's fine. It's not an issue. Now, does it matter which one is listed first on aluminum chloride? Does it matter if it's written as Cl3Al or AlCl3? It does. That does matter. That doesn't work. If possible, the positive ion is always going to be listed first. Okay, the one that has a positive charge is going to be listed first. Okay. So, we've done part 1, we've done part 2. Part 3 now, writing the word equation. If you look at the board, I'm asking you for the correct naming. I'm asking you for the states of matter, the units, and reaction type. Let's deal with the states of matter first. You might want to put this on the back of your polyatomic sheet or somewhere separate from this particular equation, because these are just kind of some notes that you'll need to write down. As far as states of matter that you can use, you can use S for solid, L for liquid, G for gas, and then AQ for something called aqueous. Now the question becomes is how do you know which one to use and why? I'm going to start with the aqueous piece because it kind of knocks a lot of stuff out. First of all, what the heck does aqueous mean? It means dissolved in water. Aqueous means dissolved in water. Now, this is not always going to be the case, but it's going to be the case for the next 2 weeks until we finish up solubility. Because solubility will change what state of matter you're going to use on stuff. But for right now, if you see a compound with 2 elements together, 2 or more elements together, put aqueous as its state of matter. That's not going to be the case forever, but it is going to be the case for the next couple of weeks until I can teach you more about the topic. Okay? So, if you see something that is got 2 or more elements together, you're going to use aqueous as its state of matter. Which leaves all the single elements. And that actually makes it really easy. Because if you look over to the left, the periodic table on the left wall there, you've got the elements with the symbols written in certain colors. And those colors are meant as a code. If it is a solid, if the element is a solid at room temperature, that means that the symbol is written in black. So if an element symbol is written in black on that chart to your left, that means it's a solid at room temperature. If it's a liquid, it's written in blue. Notice there are only two up there. You've got bromine and mercury. Those are the only two elements that are liquids at room temperature. And then last, if it's a gas, it's written in red. And you're only dealing with this if it's in, it's on its own. Yes, sir?
What if it's like not colored?
Okay, so if it's a clear one, like it's a clear or non-colored, that means that it is man-made and it's radioactive. It's a good question. Most of those are going to be considered solids, though. Okay, but it does mean that they're man-made and that they're radioactive. All right. Questions as far as how to tell if a single element is a solid, liquid, gas at room temperature? Fairly easy, right? Okay, given those sets, those parameters, put in your state of matter for the equation that you finished. So let's take a look at aluminum. Aluminum is number 13. What's the color up there? It's black. So that means that it's a solid. So I put a little S there to the right, a subscript for aluminum. Lithium chloride is a compound, and I've told you for right now, aqueous, AQ. Lithium's number 3, symbol is in black, so that means it's a solid. And then again, aluminum chloride, it's a compound. For right now, we're going to use aqueous. Okay? Questions on where I got those? Not so bad. Now we have to deal with the correct naming, the units, and all that other stuff. For those of you that have multiple pen colors, you may want to take those out. If you don't, there's no problem. I am going to set this up in multiple colors so you can see where each piece plays a role in the word equation. In general, when you write out word equations, it's not normal to put them in different colors. I'm going to put them in different colors to help teach you about the pieces. You guys remember in 6th grade you guys did diagramming in English class? Do you remember what diagramming was, where you had to pick out the noun, the verb, the adverb, adjective, and you'd put it along a line? Somebody like me, that made English a lot easier for me because I could follow the same format and I knew it was put together correctly. I'm not super creative, so it helped me. This is my format of diagramming for a word equation. That's why I've got it in the different colors. And I will then again put another code to it at the end. Do not panic and do not freak out. Okay? It's really not bad. All right, here we go. There are 4 things that have to be addressed in a word equation. The correct naming, the units, the type of reaction, and the states of matter. Those 4 things. So I'm going to use the units as in red, okay? So I'm going to put 1 mole of, then I'm going to use my states of matter and I'm going to put it in blue. Of solid, and then my name of my compound, aluminum, in black. So 1 mole of solid aluminum, and again, I'm color coding it. The conjunctions, the extra pieces, the connections, I'm going to put in green. Reacts with. Now I'm to my units again. 3 moles